Hi, good day to Mr. Rasli, and my name is Trinistian Peripantau Anatomy, metric number 101230, and today I will be talking about the introduction and objective for our project. So what is gulapong? Is gulapong important in industry? Then what is our aim for this project? So gulapong is the type of sugar palm made from the sap of the nipah palm, which is Nipah fruticans, primarily found along the coastlines and in mangrove areas of Sarawak. The Sarawak apong industry is centered around the production and commercialization of gula apong, a traditional Nipah palm sugar native to Sarawak. Gula apong is renowned for its rich aromatic flavor and is a key ingredient in various local delicacies, including the popular ice cream gula apong and apong milk tea. The industry not only sustains local economies but also preserves cultural heritage and promotes sustainable agricultural practices. These are the words from Sahari et al. In 2018. Not only that, the Sarawak apong industry is renowned for its traditional and eco-friendly products. In our pursuit to modernize and increase the efficiency of production, this project focuses on the mass production of multi-purpose apong powder. The primary aim for this project is to increase the production rate of our product, which is the multi-purpose apong powder, while maintaining high quality and sustainability standards. By leveraging advanced machinery and automation, we intend to optimize the production process. The purpose is to meet the rising market demands efficiently and position the Sarawak apong industry as a leader in eco-friendly manufacturing. Sarawak apong powder is a dehydrated, shelf-stable version of traditional apong batter, developed through a high-speed 500 kg per hour automated production line that incorporates modern manufacturing technologies to eliminate manual processes. The project features automated weighing and mixing system for consistent formulation, spray drying for rapid moisture removal, ultra-fine milling to achieve uniform particle size, and IoT-enabled quality control to ensure product reliability and efficiency throughout the production process. Next, I will be talking about the objectives. First, to create a facility layout of apong powder production and packaging with the most efficient use of space and logical material flow in a U-shaped configuration. Second, to model the apong powder production process in the arena simulation model to simulate the real-time operations of raw material storage and handling, mixing, milling, screening, and packaging. Third, to assess the mass production capacity of the system in kilogram and number of packaged bottles per day, and to assess any constraint that may be identified for future improvements. Lastly, to assess the performance of each stage of production, including machine utilization, throughput of product, efficiency of processes during and at our operation simulation. That's all for me. Thank you.
Good day to lecturer and my fellow friends. So my name is Tuan Ruli Anak Khalid with metric number 101438, and as for today, I will explain on literature review about our product, which is apong powder. So we can see here the product overview. The first one will be, it is a traditional sweetener made from nipah palm sap, where it is rich in vitamin, minerals, and low ceramic index, where it can be said a healthier alternative to our body, basically. So the next part will be the production process. So first thing first, we have to do the collection sub, where we cut the flower stack of nipah palm and collect it before we proceed to the next stage, which is the boiling stage. So for the next stage is, we boil the palm that we already collect from the previous stage to up to 4 to 8 hours. Maximum is 8 hours. So we can get at least 10 liter of sap, which is equivalent to 1 kg of syrup. So the last process will be the drying process, where we heat the powder up to 220 degrees to get the fine granules. So we can put it inside a packet of 6 into a boxes in the last stage of production line. So the next one will be the application used most. So we can see here it is often seen being used in drinks and dishes. Basically, in drink it will become one of the energy booster with antioxidant properties, which potential to support our cardiovascular health. And furthermore, for the next part will be cultural and economic impact. This is the most strong cultural ties in Sarawak, where we can support the local farmer and producer, where we can help them to get a little bit of profit from this apong powder, where they can sell their own product to the customer or to those who really want to try the apong powder, our apong powder. So the last one will be business vision. We name our company as Apong Sembilan Berhad, which is quite unique. And our main target for this project is to ensure the quality, not only the quantity that we sell, but the quality of the apong powder, so we can get the best review from the customer, and the affordability, which we sell it around 5 ringgit and 90 cent, if I'm not mistaken. And of course we have to get the halal certificate from JAKIM, so people will not be anxious to buy the thing whether it's halal or not, because we have to respect every religious in this world. So I think hopefully people will buy our apong powders. So that's all from me. Thank you.
A very good day to Mr. Rosli, and my name is Malcolm Onanak Jiru. In this video presentation, I will be demonstrating a production line simulation model that I created for our product using Arena simulation software. So this includes the design layout, the system flow, and the analysis of output performance. So our production system consists of 5 main stations. It began with the raw material handler, which will feed the raw apong into the system, simulating either manual or automated loading. And then the dry mixer then blends the ingredient to create a uniform mixture. Next, the milling or the mill will reduces the powder to the targeted particle size, ensuring proper texture. And next, the material moved to the screener or the sieving machine, which act as quality control by filtering out the particles above 100 microns. Only powder within spec 50 to 100 microns passes through, while the oversized or more than 100 microns will return back to the milling for reprocessing or rework. Lastly, the packaging machine will package the final apong powder in 200 gram bottles and finally ready for ship out. So next, why our production line layout is in U shape. So we use a U-shape layout to optimize both space and workflow efficiency. So this configuration is especially useful in small-scale production environments where space is limited and manpower is minimal. So the U-shape allows us for compact arrangement of equipment, reducing the overall footprint of the production line while maintaining the smooth material flow. So one major advantage is the ability to reroute the rejected or oversized material back to the earlier station, such as the milling machine, without requiring long conveyor path or risking misalignment. So this rework loop improves production efficiency and reduces waste. Additionally, the U-shaped design allows a single operator or supervisor to easily monitor and control the entire process from a central position. Now I will demonstrate the arena simulation. So our one entities represent 50 kilogram batch entering the system. As you can see, the material flows from one machine to another, and the decision module or the decide module in the diamond shape at the screener will check if the particle size is within range. Oversized batches are automatically routed back to the milling for processing or rework. Otherwise, it will goes to packaging. So this feedback loop helps ensure only quality powder will reaches the packaging stage. So after running the simulation for 8 hours, a total of 66 batches were completed, producing 3,300 kilograms of Aupong powder. Since each bottle contains of 200 grams, so this result in 16,500 bottles in 8 hours. So when we scale up to a full 24-hour operation, the system is capable of producing up to 9,900 kilograms or approximately 49,500 bottles per day. So from the machine utilization data shows that the milling machine or the mill process is the most heavily used at nearly 98.4%, indicating it could become bottleneck if demand increases. The dry mixer is also fairly active while the screener is underused, which is acceptable since screening is fast. So these statistic can help in scaling and resource planning. In conclusion, the simulation confirms that the machine can produce more than 10,000 bottles of Apong powder per day. Then lastly, the U-shape layout is practical and efficient.
Hi, my name is Leonardo, and I'm gonna present about the 3D printed model of our Gula Apong powder production line. We created this model to give a clear physical representation of how the production process works, from handling raw materials to final packaging. It's based on a digital layout we designed using Autodesk Inventor, which follows our arena simulation. This model includes each major station in the production line. First, raw material handling. A raw material production line is the process of turning natural or basic material into usable parts or ingredients for making a product. Next, drying. After collecting and filtering the sap, it is heated to remove moisture and turn it from liquid into a solid or powder form. After drying, the gula apong becomes solid and needs to be turned into powder. This is done through milling, where the dried sugar is crushed into a fine and smooth powder. Once milled, the powder goes through mixing to make sure the texture and quality are even. After milling and mixing, the gula apong powder goes through sieving to remove any large or unwanted particles. Once sieved, the powder goes through quality control, where it is checked for things like texture, color, moisture content, and cleanliness. Lastly, packaging. After passing quality control, the gula apong powder is ready for packaging. By printing this model in 3D, we can easily show the entire system during presentation or exhibition, helping others understand the process more effectively. It is also useful for explaining how machines are arranged and how material flows through each stage. Thank you. So this is our 3D printed model of our end product. So our project focused on the design of the end product packaging, specifically the jar that holds the gula apong powder. We used Autodesk Inventor to design the jar, considering the size, sealing method, and the label placement. Then we created a 3D printed version to visualize the end product. This helps us to ensure the packaging is not only functional, but also appealing and ready to sell. Thank you.
Hi sir, I am Wilsaris Winchester David, metric number 101344. So today I am going to explain about our project, which is finding cost estimation. The first one, we have raw material. So for raw material, we have 4 items, which is apong powder, bottle, label, and also cap. So for apong powder, it costs 4 ringgit and 40 cent, bottle 40 cent, label and cap is 15 cent. So the total price for raw material is RM 5 ringgit and 10 cent, as you can see in the slide. The next one, which is packaging and also logistic, we are selling for 24 bottles, which cost 0.05 cent each, and the shipping price is 0.15 cent. So the total price for logistic is RM 20 cent. And the third one, we have production line. which is labor, machine depreciation, electricity, and also utilities. For labor, which is workers, filling, and also capping, it costs 25 cents, and machine depreciation is 10 cents. Electricity and also utilities, we only cost for 5 cents. So the total production cost is RM 40 cents. And the fourth one is overhead and also miscellaneous, the admin management, and also contingency. Both them have cost 10 cent, so the total overhead is RM 20 cent. The total cost for these four material, which is raw material, packaging and logistic, production line, and also overhead and miscellaneous, total cost is 5 ringgit and 90 cent. For the conclusion, as you can see in the slide, we have successfully completed the MT Project 2025 within 3 weeks through great teamwork, effective planning, and continuous guidance from lecturer Mr. Rasli. The simulation shows our system can achieve up to 10,000 kg of production per day. Also, thanks to the smart U-shaped layout, feedback, and rework loop that ensure consistent particle quality. This project not only showcases our technical skills and commitment, but also sets a benchmark for scaling up upon powder production, which stands as a proud achievement in our academic and personal journey. Big thanks to my groupmate for completing this MT project and also Sir Rasli for guiding us this whole semester. Thank you.